Hello friends, welcome back to another video on Deadlock. In previous lecture, we learned about graphical methods. There are two types of graphical methods, resource allocation graph and wait for graph. In previous lecture, we learned about a resource allocation graph and we see that if graph contain a cycle and the number of instances of a resource is equals to 1, then system is into the deadlock. But if there is a cycle into the graph and a number of instances of resources is greater than 1, then system may leads to the deadlock but never ensure about the deadlock. Now let's see what is wait for graph. For example, there are two process P1 and P2, two resources R1 and R2. Resource R1 is allocated to process P2 and resource R2 is allocated to process P1. P1 is waiting for resource R2 and process P2 is waiting for resource R2. Now we can say that this system is into the deadlock by detecting a cycle in a graph. But our goal is not only to find out the cycle, but find the cycle by using the minimum space and using a minimum time, right? So our main aim is to find the cycle but using minimum time complexity as well as space complexity. Now if we analyze this graph, we can say that process P1 is waiting for R1, but that resource is allocated to process P2. So can we say that process P1 is waiting for process P2, right? Same thing, process P1 is waiting for resource R2 which is allocated to process P1. But from this we can also say that process P2 is waiting for process P1, right? From this analysis we come to the conclusion that process P1 is waiting for process P2 and P2 is waiting for process P1. So we can remove the nodes of resources which decrease the time complexity as well as space complexity. So now let's remove this resources node and directly draw the line from process P1 to process P2 and process P2 to process P1. From this we can say that process P1 is wait for process P2 and process P2 is waiting for process P1. Graph is known as wait for graph because here one process is waiting for another process and here in this graph there is no node for the resources. Hence here the time complexity and the space complexity of algorithm to find out the cycle is much lesser than the resource allocation graph. Okay, so that's it for the today's lecture. If you have any queries, here is my contact detail. You can mail me, you can message me, as well as you can contact me on WhatsApp also. So that's it. See you in the next video. Till then, bye bye, and don't forget to subscribe.